Hello, and welcome back. I am incredibly excited to present our topics for today. First up are the database builders as mentioned in the previous video. However, in the process of getting ready for this, I realized the old build tool was limited to say the least. So in addition to the database builders, we have a second topic today, the new build tool, build 2.0 if you will. I would like to apologize for yet another delay. With the rework of the build tool, it put me behind by about a month or so, but I would say the efforts were not in vain. The new tool is much more capable and provides a starting point for another technology that has to be built in the future and is critical for video games and game engines. Before I get too far ahead of myself, let's cover the heavy lifter for today, the database builder. Like the importers and exporters, builders are supported by a series of storage functions and a virtual build interface. The storage functions serve primarily to streamline the serialization process as well as enforce a strict formatting standard. The more places you have to define these translation functions, the more landmines you place in your code. By wrapping the storage process under generics, it allows us to focus on the specifics of each database builder on what matters, building database objects. Each database builder is supported by an exporter and defines three virtual functions. One function for creating an entry form, one function for creating an object based on the form details, and one function for computing the object size. We'll start by taking a look at computing the object size and some examples of the entry size functions. Many objects have no dynamic storage, meaning that whatever objects comprise them are representative of the entire data thereof. One example of this would be object instancing and spawn parameters. In an ideal world, all the serialized objects would be simple pods. Unfortunately, such is not our world. In many cases, objects will have some type of dynamic storage that needs to be accounted for. For example, cases like quests and items have member fields like titles, descriptions, objectives, etc. Understandably, these requirements would vary from entry to entry in the database, and as such, these types of objects must have their size computed piece by piece. Next, we'll take a look at the function which creates the entry form. The data entered onto the form serves as a sort of source data for the final stage, which is creating the actual database object. The create entry form virtual functions all follow a very similar pattern. We first create a unique pointer to the form and fill out the header information. We then use the entry data supplied to the function to fill out the initial data presented to the end user. The entry data is either a current object in the database that is being modified, or it is a new default object that has its initial construction values. These default strings are then turned into form lines via the createEntryLine function. In order to keep things tracked, each of the entry lines for a database builder have their details stored in a struct that pairs the line index to the line name. These mappings are used later on when reading back the data to construct objects. Depending on what you need the entry line to do, you have access to a couple of parameters that can be changed. By default, an entry line is editable, meaning that you can type directly into the field. You can supply a false boolean after the current form argument to stop this. In addition, you can also override the line function itself. By default, the line function does nothing, meaning when you press enter on the line or select it, nothing happens. The most common case I have when overriding the line function is to generate some kind of sub-helper form to fill out, and then that data is sent back to the entry line as its text buffer data. Probably the best example I can think to show would be the quest builder, primarily due to the types of data we need to enter. Taking a look at the quest builder's entry form function, we see the pattern of making the form, setting the header, and constructing the default line values. The first two lines are just the quest title and description, so these can just supply only the required arguments and leave the defaults, making it editable and do nothing when we select. Next, we have the quest objective line. This line is made not editable because the expansion form on close will return back a CSV string with all the objective identifiers. Taking a quick look at the expansion form returned from the line function, we can see that this is a helper type of form. What it does is allows you to create a series of entries by expanding the form lines. After you finish a line entry, you press enter, and it calls this new line function here, which prompts the form to create a new entry line. When the form closes, its exit function is called, and the return string is built. The result buffer is the text buffer that belongs to the entry line from which this expansion form was created. Once this form closes and returns us back to the original form, we'll see that we have our entry list, in this case the quest objectives, filled out for us in the CSV string. We also repeat this for the quest rewards. The next entry line is for entering the requisite quest identifier. Should this quest have any other that needs to be completed before it, it would be entered here. One note I would like to make is should this ever need to change to being a collection of requisite quests, in the future that change would be trivial. This line would just become another expansion form like the objectives and rewards. Following this is the line for how much experience the quest awards, and finally we have two more lines that determine what kind of events this quest triggers upon acceptance and completion. Here we see our second type of helper form, the option form. Like the expansion form, we declare these entry lines as not editable, and the form function upon selecting the line will be to create an option form. Taking a look at the option form, we see the same exit function where we are going to fill out the text buffer of the entry line from which the option form was created with our return string. However, in this case, our return string type is determined by the option form itself. Some forms need to return a bitcode instead of a CSV, when we can see that specified here. Now, technically, the quest event types aren't actually bitcodes anymore, but when this was originally created, they were, and ultimately each event can only have one type associated with it. So in this particular case, whether it's a CSV or a bitcode, it still works out the same. When the option form is being configured, it is supplied an option list, which is just a map of values to display strings. Keeping with our quest example, this is the quest event list. It pairs all of the event data values that are used in the actual game to a human readable representation. Each of these list options are read one by one, and a form line is created for the option form. When working with the option form, you select a series of list options up to the max selections value. This is done by overriding the line function to mark the line as either selected or unselected, depending on its prior state and whether or not we can make more selections. Another builder I would quickly like to take a look at is the collider builder. And I would like to show this because it particularly highlights cases in which you have to delay specific aspects of object creation. When we go to create the collider form, we are only generating an option form that specifies the underlying collider type. However, it is not until we close the collider form that we are able to build the collider information itself. If we go to the high-level form generator for colliders and take a look at the exit function, we delay the storage call from create on close until we exit a secondary form that gets created during our current exit function. This secondary form is yet another helper type and a very specific one. The collider form, as poorly named as that is, takes in our current database collider, and depending on the underlying geometry of the collider, the form creates different entry lines. At the end, we sandwich the two close-exit functions together. The main reason for doing it this way is if we take a look at the store object function, we see that an entry key uses the entry size function to determine the offset and database size. For spheres and capsules, this is a fixed size, but something like a mesh or Hall collider can store any amount of points that describe the geometry. In most cases, you're able to allow the exit function to create the object first, and then retrieve the created object out of the database and fill out dependent data. However, in certain cases like this, I wanted to highlight that where there is a will, there is a way. Moving on to our last virtual function, we'll be again taking a look at the quest builder, and this time it will be the create entry function. We begin by reading each of the form lines based on the indices we created them with. For most values, we're able to send the value string over to a build function that will interpret the data. For values built with a CSV, we'll almost always need to parse the CSV string and then build individual values from the CSV. Now, as some of you may be wondering, it can't simply be enough just to set identifiers for a quest objective or reward and call it a day. And you would in fact be what's known as correct. Going back to our high-level creation function, and these will be touched on in a future video when I go over the build tool in more depth, we see the second part of this. After we call our createOnClose function, we retrieve the quest out of the database and start to process its members that themselves require further building. For example, here the objectives are all gathered together, and when they are passed to yet another form function, in this case one that will build the objectives, this form will take in an objective and you will fill out the type of objective if we want to gather it, find it, or kill it, as well as the number of times we have to perform said objective. Upon exiting the form, we check the objective and see if the objective ID currently exists in the database. If it does, we end the objective build with our current data. If it doesn't, we call the corresponding objective data generation form function and push it onto the stack. We do this to ensure that all dependent data for one database entry exists elsewhere in the database. We also do the same thing for quest rewards. And finally, if the quest has some event type, we create another form that gives us an entry fields for the event. I think with this example, it should be pretty clear the overall pattern and how this works. You define an entry form for the base object. Then once the form has been filled out on close, you read back the form data and interpret it into the object, then store that object into the database. Then after close, if the object has more dependent data that needs to be built out, we take a reference of the object we just created and pass its members over for building. The main reason this works is because we do not actually perform any writes until we explicitly force the build tool to export the current database builders. At this time, the current database entries are iterated over and spat out into their respective databases. By doing this, any references we have out in tertiary builds will carry over their data in due time. Now that we have covered the virtual interface, let's go over the storage functions. The two primary functions we have to look at are storeObject and exportDatabase. The storeObject function will simply compute a key based on the object, and if it currently exists, we evict the entry and key, then insert them into the database builder. Finally, we update the total database entry size and then store the entry name and ID as a symbol pair. This symbol map is used during the build process so that dependent data calls may be retrieved back to the string that created their identifier values. The next storage function is the big one. When we go to export a database, we will first write out the header data, which in most cases is simply the number of entries in the database. When the world chunk data is exported, it has its own header that also describes the world extent parameters. After we've exported the header object, we then iterate over each of the entry keys in the database. The keys themselves are stored as an ordered set from least to greatest. I touched on the reason for this in a previous video, but the primary choice was so that we can do a binary search over the entries so that we can avoid doing an O event search during runtime. You could do greatest to least, it just has to be an ordered set of the entry keys. For each key, we are first going to write the table of contents entry. This will compute a write position for where the table data will be stored, as well as a position for where the key will be stored. After we export the key into the table of contents, we also return the write position. Once we have the write position, we will move to it in the file and begin to export the binary data using the exporters we covered in the last video. If this is confusing, I found visualizing the database as it gets built really helps. We first start with the header object, then we write out one key at a time following the header object, skip into the database to our right position, and export our object. We continue this for each key until we have exhausted the list. I would like to switch gears now. You've already had some exposure to the entry form and entry lines, however, it was from a more functional standpoint. I want to now talk about the architectural considerations made during the development process. As mentioned earlier, this video was supposed to already be done and out. However, about 3 weeks ago or so, I was trying to get some footage using the original build tool to create a small game demo, and it was just horrid. It didn't feel good, it didn't work well, it was just a mess. So I figured this is probably the sign to go ahead and actually make a real build tool that looks like it was designed with some intent. Ultimately, I would still like to expand the current tool to move away from a CLI altogether and instead use a GUI tool. I recalled two things during the design phase of this that really stuck with me. The first was the pretty standard GUI approach where windows and other objects are spawned in a stack and a child must first be closed before the parent window or object is closed. And this effectively allows you to just unwind the stack back to the previous state when you're done with the current object. The second, I believe, came from a comment I heard on the Primogen stream one day about a good GUI tool comes from a good CLI tool. At least I believe it was him, and if not, I profusely apologize for that hallucination. Nonetheless, I ultimately decided to kill two birds with one stone and began the arduous process of building out the GUI platform. Currently, we have no actual graphics, but what we do have is an abstracted form and line concept that are currently being used by a custom console class to display our current form output. In the future, I see it being more than permissible to simply reuse the same form and line structures for GUI windows and objects. I don't want to opine too much on this for now as it's a technology I haven't began to work with yet, but from my very limited research, this seems to be a valid approach. And very briefly, this is the console class. I will be going over this in the build tool in more detail together in a future video, but for now, this is it. I'm not even going to front like ChatGPT didn't write this constructor. The form class itself is very lightweight. It's a header line, a map of body lines, as well as a tracker variable for the current line and a function to execute on close. This is the base class used when deriving all the other helper forms. Form line has a little more going on, but it's roughly the same thing. Some tracker variables, whether or not this line is active and editable, a function if the line is selected, and a name for the line as well as the text buffer. And this text buffer is the buffer that we saw being used in this series of build functions when creating data. Currently, these backspace, delete, and insert functions are pretty jank, but they show the intent of what the text buffer is supposed to be. Ultimately, you will route all modifications through the build tool and the text buffers to ensure a single point of failure. Likewise, these two will be gone over in more detail as well in the future build tool video. Now, usually this is where I would give my thanks for watching and briefly cover my intents for the next video. However, I am too excited to not show the tool in action, and even though the underlying framework needs a little more work to move us across the finish line, I want to give a little demonstration of the technology in action as it currently stands. So before I close this out, here is a recording of me creating a very small tech demo with the new build tool. Okay, so this is, I suppose, the debut of Rain and Rain Engine, or the build tool, as we've been calling it. So this is the test scene that I want to go ahead and recreate using what we just went over. So starting off, I'm going to launch up the build tool, and I will go down and export, and this is going to basically reset all the binaries, all the databases there. Now we will hop into the build tool. First thing we'll do is create some terrain and the player. And I must note that player and player instance right here are critical. If you want to create the player, it has to be done that way. Every other object can be named whatever. And even the player can have its own name per se, like we see here, player underscore name. So the player will be part of the graphics, the AI, and have its own inventory. It has no interaction, and it is an entity. It's going to have a sphere, everything's going to have a sphere collider actually, just for testing. We'll set its speed to 10. I'm going to give it no items, just set a blank inventory. And don't worry about the combat values, just the combat ability for now is all we need. I'm going to name it Slash, and it's going to deal 25 damage. It's going to be an offensive ability with a damaging effect. We'll give it a cooldown of 1, even though the global cooldown is 2.5 seconds, so it doesn't really matter. Again, 25 damage, and this just signifies that it's going to apply once over 1 or after 1 second. So we'll make the player a cube and give him the blue material, and we'll spawn him near the end of the map. And actually, I made a mistake. It's not going to apply over 1 second. What it means is after 1 second, apply it again, but the rate only lasts 1 second, so it's a tick once. It's kind of confusing, but it's more for when the combat gets matured and we have things that like linger over time. So we re-import the database and we create our first quest giver, Mr. Kalon Salvatore. Create an instance of him called Kalon0, which comes from Kalon. He's just going to be a quest giver. Again, our good old sphere collider. And we want to set his inverse mass to 0. This way that gravity and everything will still pull him to the ground, but the player can't actually move him. So the first quest is going to be the find gate. And this is simply just going to have you go and look for a demon gate. Technically it's a demon gate trigger, but we'll go ahead and make an actual object so we have some visual representation out in the world. It's also going to give you a gold coin and 100 experience, which don't do anything right now. And then on accept and complete, as you see here, it's going to toggle a quest trigger called Demon Gate. By default, the Demon Gate trigger shouldn't be active. So we're going to need to turn it on when we accept and then turn it back off. Get our gold coin. It's just currency. It has no effects. And actually I spelled coin wrong there. I'm going to need to go edit that. We'll get 10 for completing it. And then now our objective is we want to find one Demon Gate. And this is that trigger. So the trigger is going to be at 100, 6, 100. It's going to give it a 10 unit radius. It's a location discover trigger event. We only want the trigger to go once, and like we said, it's deactive by default, or inactive by default. So I actually messed up here. This should be the magenta material, but don't worry, I'll realize that and go back and fix it. We'll spawn the Kalon0 instance down by the player. And then we'll go ahead and export and then re-import just to make sure that what we just built doesn't get ruined if we make a mistake. And now we'll go ahead and go in here and create that Demon Gate instance. So we'll make the Demon Gate object. It's just graphics for now. No interactions or anything. Give it the sphere collider, radius of 1. Again, we'll want this to not be moved by the player or other objects, so we'll give it a mass of 0. And this is where I realized that I gave Kalong the wrong material. So we'll go ahead and spawn the Demon Gate, and then we'll go down to Kalon's graphic object, and we'll replace red material with magenta material. I'll go ahead and export. All right, and there is a very red terrain in Kalon. Right now the terrain is just pulls whatever texture was used last in OpenGL. And there we go, our quest trigger just went off. Go back over to Kalon, right click to interact with him, turn in our quest, and we get our gold coin. Okay, so now let's go ahead. We will re-import our databases. And now let's make our second quest giver, Mr. Velgar Emberforge. Make a new instance, Velgar0. It's going to come from a Velgar object. Name Velgar Emberforge. And he is just a quest giver. Give him our trusty sphere collider. And again, we want his inverse mass to be 0. The first quest he gives is going to be to kill some orcs called Slay Orcs. Well, that's the identifier. The quest name is Kill 'em All. And we want to, for this one, just go ahead and kill 5 orcs. Our objective is going to be orc. We're going to get a gold coin for it. Again, some more useless experience. There's no events on this one. And here I was debating making it, kill one orc just for sake of testing, but Quest says 5, so we'll go ahead and kill 5. Just simple name orc, and the orcs are going to be part of the AI and the combat. Give them a speed of 7, and by default they can just use the slash ability that the player has. There will be Wanderer and Hostile, and they will also be mobile and melee capable. And since they're orcs, we'll go ahead and make them green. And Velgar as well, he's a quest giver like Kalon, so we'll go ahead and make him magenta. And we'll spawn Velgar over down by the player. And now we need a way to make sure we actually have orcs in the world to kill to complete our quest. So we'll go back into our Demon Gate object, and down at the bottom, we're going to make it a object spawner of the type orc. Place the spawner over at 100 and 100, and we'll spawn it every 4.5 seconds up to 5 orcs. And we'll spawn the orcs within a 25 unit radius. Go ahead and export. And let's see. All right, there is our Mr. Velgar with Kalon, and now we see that the Demon Gate is spawning some green orcs. Go ahead and trigger that, and we'll start working on our orcs. So 2 things I want to note. One, the AI is not smart at all, so if anything is hostile, it will try to kill anything else, so these orcs are going to start trying to attack one another. And 2, the AI isn't actually doing anything right now, it's about to, but the game is in debug mode, and because the nav mesh has to be built, it takes quite a long time in debug mode. And here we see I'm about to start getting cucked. Need 2 more orcs, and they keep killing each other, so I'm going to take this guy and body block him. And let's start working on this last guy. And we have no more orcs we need to kill, so we're going to return to our quest givers, interact with Kalon, interact with Velgar, complete our quests. And that is where I'm going to go ahead and call it for now. I appreciate you guys coming along for this journey, and I will return you to the main video. Thank you so much. And with that, we have covered just about everything for today. If you have any questions, comments, or concerns, please feel free to leave them below, and I would be more than happy to get those addressed. In the next video, I think we'll finally be getting around to creating the one big beautiful binary. As previously advertised, the manifest binary database that games run off of are supposed to be a database of databases. However, as you saw today, they are each exported individually. The primary reason that is being done for now is testing. Once the databases get compiled together, validating individual entries and debugging will become astronomically more challenging. So that has put off for until now when we are more or less happy with the database builders and larger scheme as a whole. Thank you all so very much for your time. I hope you enjoyed this and have a great rest of your day, and I will see you in the next one.